Namaskar viewers and welcome to our today's episode. Today we are going to talk about a topic that affects millions of farmers across the India and the world, the acid soil. What is acid soil, why it is a problem and how we can sustainably manage it? To answer all of these questions, we are joined by Madam Prabha Devi, Scientist Environmental Science at ICAR Research Complex Umiam, Meghalaya. Welcome ma'am to the podcast.
Namaste. It's a pleasure to be here.
So ma'am, before we can solve a problem, we must first understand what the problem is.
Yes.
So can you tell our viewers what exactly is soil acidity?
Okay, Susitra. Soil acidity is the concentration of the hydrogen ion in the soil solution.
Okay ma'am.
So, any soil whose pH is less than 7, they are considered as the acid soils. So, lower the soil pH, higher the soil acidity.
Okay,
So, specifically, acid soils are those soils whose pH is less than 6.5 and if the pH is less than 5.5, it is considered to be strongly acidic.
Okay.
And these acid soils are characterized by lower cation exchange capacity than sandy to sandy loam texture soils, and they have base saturation less than 70%, and they also show toxicity of certain cations like the aluminium, manganese, and also they show deficiency in some other nutrients like the calcium, magnesium, molybdenum, phosphorus, etc.
Okay ma'am. Now we know what acid soil are and how they are defined. So the next question which comes in mind is why acid soils are a problem that we should be concerned about.
Okay, Chitra. So these acid soils, they pose a significant challenge in the sustainable agriculture system.
Okay ma'am.
Due to its inhibition in the soil fertility, then crop production and environmental health at large.
Okay ma'am.
So the primary concern associated with the soil acidity, as I said earlier, it is associated with toxicity of some of the cations such as the aluminium, then magnesium and iron also. And in such conditions, there are also like deficiencies of certain nutrients like the phosphorus, the calcium, boron, molybdenum.
Yes ma'am.
And it inhibits the development of the root, then the nutrient uptake and the growth of the overall plant health.
Okay ma'am. So ma'am, knowing these problems tell us that soil acidity is a serious concern for our farmers and we have to tackle it very properly.
Yeah.
So are there any types of soil acidity?
Yes, Chitra. Basically, there are 3 types of soil acidity. The first one being the active acidity. The second one is the exchangeable acidity. The third one is the residual acidity.
Okay, ma'am. So, ma'am, you have mentioned active acidity, exchangeable acidity, and residual acidity. So, ma'am, let's go step by step. Can you tell our viewers what is active acidity?
Okay. Active acidity is the concentration of the hydrogen ion in a soil solution at a given point of time.
Okay,
it is a very small fraction of the total acidity in the soil, and it determines the direct pH of the soil, and often it is very dynamic, and it gives response to any kind of soil management like the liming or any kind of fertilization.
So now ma'am, we have understood what is active acidity. So let's move on to the other 2 types, which is exchangeable and the residual acidity. So can you tell our viewers what they are and how they affect our plant?
Yeah, sure. So this exchangeable acidity,
yes ma'am,
it is the concentration of hydrogen ion and aluminium which is loosely bound on the surface of the soil colloids.
Okay ma'am.
So this is it can be easily displaced by other cations also.
Okay ma'am.
So higher the exchange acidity, so it will pose a higher aluminium toxicity.
Okay ma'am.
It can be removed by plant uptake or liming, and it is very toxic to the plant roots, and it interferes with the uptake of the nutrients, especially the phosphorus.
Okay ma'am.
So coming to the residual acidity,
yes ma'am,
it is the largest fraction of the total soil acidity, and it is the concentration of the hydrogen aluminium that is tightly bound to the soil colloids, and also with the mineral structures and the organic matter. So it is not easily exchangeable, but it is only available after chemical weathering or through liming process.
Okay, ma'am. So, ma'am, this gives us a clear picture about what are the types of soil acidity. So, ma'am, now we would like to know what creates such acidic condition in the first place. Like, what are the main causes for the acid soil formation?
Yeah, sure, Chitra. This acid soils are being formed due to a combination of the natural processes as well as the human-induced factors.
Okay, ma'am.
The first factor being the acidic parent materials such as the granite, then the shell, then sandstone and quartz. These have like low basic minerals, and the soil which is formed from these minerals, they are dominated with alumina and silica, due to which it leads to low base saturation and higher soil acidity. The second one is the leaching due to the heavy rainfall, and it is the main natural process that leads to the soil acidity. And in this process, basic cations such as the calcium, magnesium, potassium, sodium, they are being leached out and it goes off. And this is very prominent in the high rainfall areas, such as the Northeastern area states of India. Then the third one is the presence of silicate clays. These are very common in the Eastern Ghats, Chhattisgarh and Jharkhand. And the fourth is the prolonged use of the acid-forming fertilizers such as the ammonium sulfide, ammonium chloride and urea. This leads to like higher soil acidity. And the fifth one, this is the like acid rain. This is a little rare, but it is very like we can see this kind of situations in industrially polluted areas and the coal mining areas, where the gases from these polluted areas such as the sulfur dioxide and the oxides of nitrogen, they mix up with the atmospheric moisture, forming acids like the sulfuric acid and the nitric acid, and when it falls on the surface, it lowers the pH and it can cause the soil acidity.
So viewers, understanding the cause help us to target the right solution. So now, ma'am, can you tell us about the key management strategies that can help us to reclaim the acidic soil for the sustainable production?
Okay, for reclamation of such acidic soils, there are some approaches. Some of the major approaches are like liming, then use of biochar, then application of some organic manures. Then there are also like some studies have reported the use of industrial byproducts for the management of acid soils.
So ma'am, among these, liming is mentioned first. So can you tell us about how liming is applied and what benefits liming provide?
Okay, liming has proven to be one of the most promising approaches for management of the acid soils, and it increases the soil pH and the buffering capacity of the soil. And it is also known to increase the nutrient use efficiency, especially the phosphorus and the nitrogen. And it is shown to decrease the aluminum and manganese toxicity, increase the microbial activity, then increase the organic matter decomposition. It is also like known to increase the biological nitrogen fixation, and it also promotes the better root growth and for a better crop establishment. And overall, it increases the soil structure by promoting flocculation of the clay particles and leading to increasing in the aeration and water infiltration. So the lime application is based on the buffering capacity of the soil itself, but in general, it is the recommended dose is from like 0.2 to 2 tons per hectare, and it can be applied 2 to 3 weeks before sowing in a band or in a furrow application type.
Ma'am, recently many experts are recommending biochars.
Yes.
So can you tell how biochar is used in acidic soil and what advantages it offers?
Okay, so biochar derived from the crop residues like the wood chips, etc. They are known to be very helpful in amelioration of the soil acidity. And these biochars, they are very alkaline in nature. It has pH in the range of 8 to 10. So they contain a high amount of carbon, ash, and many minerals. It can it has a high capacity to absorb the cations such as the exchangeable aluminum, then iron also.
Okay.
And it also provides base cations such as the calcium, magnesium, etc.
Okay, ma'am.
And it is known to increase the cation exchange capacity of the soil.
Okay, ma'am.
Then it also promotes the microbial biomass. It increases the soil buffering capacity. Then it is also known to decrease the soil compaction.
Okay, ma'am.
And it also supports the water retention for a very long time. So the biochar, it is applied in a general dose of 5 to 10 tons per hectare.
Okay.
Over a multiple season.
Okay.
And it is a good approach.
So, ma'am, alongside biochar, organic amendments are another traditional approaches.
Yes.
So, can you share how organic amendments are useful in the soil acid management?
Okay, so organic manures such as the FIM, compost, then the green manures, vermicompost, crop residues, they release a lot of basic cations during the process of their decomposition.
Okay, ma'am.
And this method, it increases the microbial respiration, and it also increases the nutrient cycling process. And all of the organic manures, the poultry manure is proven to be the most effective, as it has a high calcium carbonate equivalent in the range of 35 to 45%. And it is not only a nutrient source but a very good buffering material.
Ma'am, organic amendments are very common in farm, but I've also heard that some industrial byproducts can also be used. So can you tell which industrial byproduct can help in management of soil acidity?
Yes, rightly said, Chitra. Some of the industrial products are being used for amendment of the soil acidity. Then some of them are the number one being the fly ash. Actually, fly ash are the byproducts from the thermal power plants where
Okay,
the coal is being burned.
Okay.
So out of the byproducts, we have the bottom ash, then the fly ash. So the fly ash we are targeting. So the fly ash is of again different types, like the acidic fly ash, then the alkaline fly ash.
Okay,
So
ma'am.
for them to use for amendment of the soil acidity, we would be preferring the alkaline fly ash.
Okay,
So this fly ash, not only it neutralizes the soil acidity, it also improves the soil's texture. It supplies secondary nutrients to the soil.
Okay, ma'am.
And usually these fly ash are applied in the dose of 5 to 15 tons per hectare.
Okay.
So another industrial byproduct is the steel slag,
Okay.
which is a byproduct in the steel manufacturing plant. So it increases the soil pH, and it also decreases the exchangeable aluminum. Then
Okay,
it also supplies available silicon to the plant, and this silicon, it plays a important role in improving the stress tolerance in the acid soils.
Okay.
It also increases the phosphorus availability through competitive sorption and slow release of nutrients over time. So the third industrial byproduct, it could be zeolite. So zeolite can be of natural origin also, and it can be synthetic. So what is this zeolite? This zeolite are crystalline aluminosilicate minerals that are originated from the volcanic eruptions.
Okay.
And they are very porous in nature and has a high ion exchange capacity.
Okay.
So it not only increases the soil pH, but also absorbs a high amount of cations like the aluminum, then the hydrogen ions. So it has the capacity to buffer the nutrient release and increases the microbial habitat. So in general, it is applied in the range of 2 to 10 tons per hectare, and it is very effective in management of the overall soil
So, ma'am,
health.
these are the very innovative approaches the farmer can consider. So, ma'am, beyond these main methods, are there any additional practices which a farmer can adopt to improve their soil acidity?
Yeah, certainly, Chitra. There are some approaches like the balanced use of the fertilizers, then use of the biofertilizers, and using some good agronomic practices.
Okay.
So for balanced fertilization,
Yes,
we should avoid overuse of the ammonium-based fertilizers.
Okay.
Then we should prefer better use of the nitrate-based fertilizer alternatives, and the use of rock phosphate and phosphorus in banded form. This will reduce the fixation also, and application of micronutrients such as the molybdenum, then boron, wherever it is deficient, and use of acid-tolerant PGPR and phosphate solubilizing bacteria and the mycorrhizal fungi. This will increase the nutrient use efficiency. Then there are some agronomic practices like the contour bunding, then the terrace farming. Then we should also adopt the minimum tillage to reduce the decomposition of the organic matters. Then we have this mulching, which will not only address the erosion but also increase the moisture retention in the soil. And also we should prefer using the cover crops.
Okay, ma'am, since acid soils are particularly common in the Northeast India, so can you give some specific suggestions for the farmers of that region?
Yeah, certainly, Chitra. There are some approaches like the site-specific lime application based on the pH buffering capacity of the soil and the soil texture. And the second is the promotion of the integrated nutrient management, which uses organic manures, then biofertilizers, and there is minimal use of the chemical inputs. The third one could be the agroforestry approach to protect the slopes and to increase the organic carbon in the soil. Then the fourth one is capacity building of the farmers. I think this is very much important to make aware them of the use of the lime, then the varietal selection and the cropping strategies also. And the fifth one, again, it is very important. This one is to establish a lime bank, which should be made very accessible to the farmers for the lime procurement.
As we have heard, acid soil management is not a one-time effort, but it is a continuous process in which we combine the traditional approaches like liming and using organic amendments along with the innovative approaches such as biochar, fly ash and zeolite. This will transform our low productive land into a fertile ground. And I would like to thank Ma'am Prabha for her valuable time and sharing this wonderful knowledge with our farmers. That's all for today's episode on the acid soil management. If you find this video helpful, do not forget to share it with your farmers, friend and family. Stay tuned for the future episode on sustainable agriculture practices. Thank you.